Cost and Performance Optimization in Amazon RDS webinar. My name is Greg Kerala. I will be your presenter for today. We have with us Sergey Sokolenko, who is a Senior Product Manager at Amazon Web Services. Sergey will be our Q&A moderator. A little background about myself. I've been at Amazon for about 16 months. Previously, I worked at Intel and at Oracle in database technology. Before we begin, I would like to walk the audience through a few items. On your screen, you can see a Q&A panel. Please submit your questions at any time during this webinar. Sergey will answer as many questions as time allows in the Q&A panel while I am presenting. Towards the end of the webinar, there will be a Q&A session and a few poll questions for us to collect audience feedback. I will address some questions by then as well. Lastly, this webinar is being recorded. We will share the recording and the presentation slides via email a few days after the webinar. First, I just want to go through the agenda of what I'll be covering. First, we'll talk about instance and storage selection. Next, we'll be covering some issues around monitoring. And finally, we'll cover an instance class essentially refers to the amount of compute and memory and network performance that you can expect by an individual instance selection. Some criteria that you'll use to select the correct instance will be performance, cost, region, and of course, engine. And by engine, we mean one of the 4 relational database engines that are supported within the RDS service, those 4 being Postgres, MySQL, Oracle, or SQL Server. And of course, importantly, with instance selection, a real differentiator between perhaps your business as usual and on-premise, as well as between that and your relational database service, is that you can very easily scale your instance up and down. By that, I mean you can start off with a very small instance with perhaps just one virtual CPU and just a handful of memory. And just through a simple API action or through a drop-down box, you can select all the way up to 32 virtual CPUs. And you don't have to migrate any kind of information. You just simply select the new instance type. And then, of course, if you start off with a larger instance type and realize you're not using the full performance of it, you can very easily scale down in terms of selecting a new instance type. One note for instance type selection, and when I change that selection, it does require a restart to the database. So use that with caution, but it's certainly available to be able to dynamically go up and down in your instance selection. So here's a slide that I just wanted to provide a quick overview. It's on our web page as well. Hopefully the type and font is not too small, but I just wanted to give you a sense of the current generation for instances and the number of compute and memory, whether or not it's optimized for provisioned IOPS or network performance. So here, as I mentioned earlier, you can start very small with one virtual CPU and just 3.75 gigabytes of memory, all the way up to 32 virtual CPUs and 244 gigabytes of memory, depending upon your workload. And there are some interesting things with micro instances, the T2 instance type that I'll be covering later on. Essentially, this allows you to burst your CPU performance as well. In addition to the current generation, we support previous generation. So existing customers, perhaps you're on one of these previous generation instances, and you can see what those are. And I'll be doing a little bit of a comparison later on between previous generation and newer generation instances as it relates to cost and performance. So how do I make the correct instance type selection? Of course, we mentioned some broad factors in the beginning, including cost and region. But of course, from a database perspective, we first want to measure our existing workload if we're migrating from an existing system, or we want to make some estimates in terms of usage and write and read throughput that we're expecting from our system in case it's a new system. So how can I essentially measure my existing system? Of course, because we are exposing 4 relational database engines, we don't add or subtract anything from the operation of those databases. We just provide some automation in terms of backups and high availability. So what that really means is that you can use your standard database engine tools to be able to measure your existing workload. These are things such as Oracle Enterprise Manager or SQL Server Tuning Advisor, which for your existing workload should give you a good starting point when you want to switch to the RDS environment in terms of making the correct selection for virtual CPUs and memory allocated to your new database. Of course, once the database is in RDS, I want to then start using CloudWatch metrics, which we have a section under our monitoring to go into more detail. But essentially, CloudWatch metrics are the way within the RDS service that you can look at key parameters such as memory, compute resources, as well as I/O throughput. So of course, by using CloudWatch, if I notice that I'm either overutilizing my resources or underutilizing them, I can then test and scale accordingly. And that goes back to our previous conversation in terms of being able to very simply change your instance type selection through the API or through the console in terms of selecting your new instance type and then hitting apply or deferring that application of that instance change until your next maintenance window. So I think those are the basics in terms of the choices in instance type selection. Of course, the more virtual CPUs, the more memory. Generally, the better performing my database will be. So for very high concurrent or transactional workloads, we would recommend the larger instance types to be able to provide more compute and memory resources to the database. Then, of course, once we've selected upon our correct instance type, we then want to look at some storage options. So within the RDS environment, you essentially have three different components. We'll be covering general purpose storage first. Just for completeness, the other two choices are provisioned IOPS and then the older EBS storage, which is based on a magnetic or the magnetic disk technology. So by default today, you'll notice that was launched about 6 months back, which is general purpose SSD storage. It's a new volume type, which is all solid state drives. And importantly, it is the new default volume for RDS. So if I'm starting a new instance type, by default, we will provide the selection for general purpose storage. It's available on all instance types and all databases in all regions. And importantly, it provides a flat per gigabyte I/O rate. So for every 1 gigabyte I provision, I get 3 IOPS, and it scales linearly. So if I provision 10 gigabytes from my database, I can expect at a steady state 30 IOPS, all the way up to 1 terabyte provisioned of SSD storage. I will then get 3,000 IOPS at a steady state. Then, of course, the general purpose storage is also burst capable of up to 3,000 IOPS for limited periods of time. So if you have a very bursty workload, customers will choose general purpose storage to be able to accommodate the steady state as well as the burst transactions against that database system. And by bursting could either be increased in terms of users or it could be something like data loads. And I'll cover a little bit more detail of that here in a second. So how do I size my database storage? Here's just some basic rules of thumb that we'll use. So of course, the default way of thinking might be to say, well, my database currently occupies 500 gigabytes. Therefore, for safety sense, I'll give it 750 or perhaps even a terabyte just so I have room for growth. And that certainly makes sense from a basic sizing perspective. The other way that we are presenting here is to think about, instead of the raw amount of storage, is to think about it in terms of IOPS. So because general purpose SSD storage gives you at its baseline 3 IOPS per gigabyte, you could actually provision based upon your IO requirements. And so here is a simple example where I'd like to have 1,500 steady state IOPS. Therefore, I will provision 500 gigabytes of SSD storage. And because I'm not paying for the additional cost for the I/O, depending upon your workload and your scenario, this could actually be cost savings. And we have some charts in a few slides to illustrate this point further. And then, of course, as I mentioned, SSD does provide I/O burst support. So if you're doing large table scan operations infrequently, or you have a spiky workload, the SSD drives can support up to 3,000 IOPS for a limited period of time. And then once I have exhausted my credits for the burst, I can actually refill that by having my IOPS or my baseline I/O below the steady state I/O, and I'll be accumulating credits back into the bucket to be able to support for future burst workloads. Okay, so that's the first one I talked about, was using the default, which is our new SSD storage with 3 IOPS per gigabyte. The other way is to look at provisioned IOPS. Provisioned IOPS is also SSD based. However, it is you can actually specify an exact amount of IOPS. So today we support at the maximum a 10-to-1 ratio, which means that for our current, for instance, I'll use an example of MySQL. We currently support a maximum of 3 terabytes. Therefore, you at a 10-to-1 ratio, you can provision 30,000 IOPS for that database. And this will give you fast and consistent I/O performance when required. So by default, for any production database that has um, 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 I/O intensive or OLTP type system, by default, we would ask you to recommend provisioned IOPS for that storage setting, just so I can have consistent I/O if I'm not able to achieve that through my uh, general purpose SSD storage with the baseline of 3 IOPS per gigabyte. So we see a lot of customers that are running provisioned IOPS today, and it gives them that assurance that the RDS service can meet their production application workload needs. So some things that impact storage performance, these are questions that we frequently answer to customers. So remember that when I'm doing my nightly backups, and just for a quick refresher, for those of you that are not familiar with the backup window, when I launch an RDS instance, I specify a nightly, it could be a daily 30-minute backup window. Of course, that could be at night, or it could be at the time of your choosing. But during that 30-minute window, your database is still online. It's still available to receive the full amount of transactions. However, you could see increased I/O during the actual period the backup is being taken. Therefore, you should account for that when choosing that 30-minute window. And of course, the database remains open and transactions continue to be accepted into the database. It's just that we would expect higher I/O during the physical backup of your database. And we just put in here from a cost perspective, remember that within the RDS service, we do not charge extra for the storage that the backups take. So you actually get 100% of your storage volume for however you provision your database. So if I give my database 1 terabyte for free, I get 1 terabyte to store my backups. If my backups for some reason go beyond that 1 terabyte limit, then I will incur a small S3 charge. But you'll get 100% of your provision database storage for your backups included in the per hourly charge for the RDS service. So some things to think about from a maintenance window perspective. So I mentioned the nightly or the daily 30-minute window. Of course, could be at night or could be at your time of your choosing when I launch an instance. The other time period you select is your maintenance window. And so this is a weekly 30-minute window that you tell us this is the time when, if there's any patching activity or any kind of maintenance on that database, when it's acceptable for that period of time. Now, the vast majority of cases, no maintenance occurs. If a patch is scheduled to be applied, we generally, our goal is to provide a minimum of 2-week notice, and you'll get an email when that will occur. So that's kind of the basics of the maintenance window in a few sentences. But from a backup perspective or storage perspective, just think about some things that you want to do during that maintenance window beyond, patching or other kind of activities, because you have specified that 30-minute weekly window as a period of time when it's acceptable to have increased I/O. So this could be when you take your own manual snapshots of your database. Again, just like with the nightly backups, the manual snapshots will potentially increase your I/O. If you want to make a modification to your database, such as switching from single AZ to multi-AZ modifications, or if I want to create new read replicas. The reason we mention those is because all of those actions will potentially increase your I/O usage, which then could impact the overall I/O throughput for your database in the production environment. So a couple of caveats for the storage. Just remember that you can dynamically change the amount of database storage has been allocated for both provisioned IOPS as well as the general purpose storage. And what this means that I mentioned in terms of instance selection previously that if I go from one instance class to another, that a restart of the database is required to make that change. That is not the case with increasing my storage. I can start off small, let's say with 500 gigabytes of storage. I could increase it to 1 terabyte, to 2 terabytes, to 3 terabytes, which is our current maximum for 3 of our engines. Of course, for SQL Server, the current maximum is 1 terabyte. So I'll be able to dynamically change for 3 of the engines the amount of storage, and that's a one-way operation going up. So I can start at 500 gigabytes, go to 1 terabyte to 2 terabytes. But as you can imagine, because we are allocating storage behind the scenes, we currently do not allow you to shrink. It's a one-way operation. And of course, scaling storage again could increase I/O performance, or could increase I/O during the time that the new storage is being allocated. Therefore, I could potentially see decreased I/O throughput until that operation is complete. So I did mention a couple of caveats for SQL Server. So with SQL Server today, we do limit that to a total of 1 terabyte, as well as the scaling storage operations are currently not supported with SQL Server. So I need to initially size my SQL Server environment for my anticipated future growth, because I can only scale storage with Oracle, MySQL, and Postgres today. Okay, so here's a couple of basics. So I mentioned we do have a little bit of an acronym. We call it GP2, and that GP2 is just our way of referring to the standard SSD storage that we were talking about previously, as well as we talked about an instance type T2, which provides burst capability. So I did cover that at the baseline, GP2 storage, again, which is our general purpose SSD storage, provides 3 IOPS per gigabyte base performance, and then you earn credits that can then be used to burst up to 3,000 IOPS based upon the amount of GPT storage I've allocated. So it really provides a nice way to take into account situations when I might have higher I/O than my baseline and be able to still deliver great performance. Similarly, the T2 instance class is similar in terms of its bursty. However, this time we're bursting CPU performance. So GP2 storage bursts I/O, T2 bursts CPU performance. And so we want to be able to look at some of these and then see how this could potentially impact the cost and performance of my system. So here's just a quick visual way to look at those things I was just talking about. So because I get an initial amount of credits for GP2 in terms of I/O, bursting I/O up to 3,000 IOPS, as I mentioned, as well as I get an initial amount of compute credits on the T2 instance type. We did a simple test in which we maxed out both the I/O performance as well as the usage of the compute units, just to illustrate the previous point. And so here you can see when I started this particular test for the first, I believe it's about 2 hours or so, I'm able to deliver 6,000 transactions per second, and I can see both the I/O and the CPU usage. And you can see where the GP2 credits are exhausted. I'm then down to 3,800 transactions per second because I'm at the baseline of my I/O throughput. And then once the CPU credits are exhausted, I see a small decrease in the transactions per second down to 2,200, which will then be my baseline. I combine the expiration of both my CPU and my storage credits. So here's just a different way of looking at this. Of course, you can monitor this, the CPU usage in CloudWatch metrics. And so here you're looking at your CPU credit balance line. It'll go down to your baseline eventually. And this then can show the CPU on your instance as well. And you can see where the spike occurs, where the drop occurs in my CPU utilization corresponds to where I had completed the credit balance for my CPUs. And therefore, going forward, I'm at the baseline CPUs. And I will need to go below the baseline to start accumulating more credits into the capability. So how does that all come together? So let's just, we started off with a little bit of a text explanation, and we try to show a few charts to make it simple. But let's put these things together and look at how these can impact cost and performance, looking at burst mode, standard versus provisioned IOPS. Slide, the yellow line that says 50.575 per hour, what that's referring to is an M1 medium with 200 gigabytes of standard storage. And that will give you around 1,100 transactions per second. We're referring to the 0.75 per hour. That is, of course, a M1 medium with 200 gigabytes of standard storage. The line above that is going to show us if I added an M1 I'm sorry, if I went to an M3 medium with 200 gigabytes and 2,000 IOPS, that then comes to about 40 cents per hour, 41 cents per hour. If I move on to a M3 large with 200 gigabytes and 202,000 IOPS, that refers to 51 cents per hour. Look at is if I were to go forward, I could see that at 50 cents per hour would be an M3 large, and then if I went and added a T2 medium with 200 gigabytes per second, and I'll just kind of walk through these real quickly. The final end of this is that if I were to add a T2 medium with 1 terabyte of GP2 storage, I could end at 23 cents per hour. That'll give me a bursty workload up to 6,000 transactions per second. And then as I expend those credits, it'll actually be around the same price per performance as an M3 medium. So let's go on to scale and performance. So how do I scale an RDS instance? So of course, we mentioned this, that you can scale up or down with resizable instance types. You can scale your storage with a few clicks, as we mentioned. So you can scale while you're online for MySQL, Postgres, and Oracle. And then you can actually convert between standard and provisioned IOPS if your IO throughput requires provisioned IOPS based upon your workload. So those are kind of the two standard ways that we mentioned earlier. The third point that we want to mention is if I put a cache in front of my RDS instance. So this is for situations where I have a heavily read-intensive operation. A lot of our customers will look to using Elasticache from Memcached or Redis, which is essentially an in-memory data cache that I can place in front of my RDS instance for scaling from a read perspective. And of course, because the RDS engines are your standard Oracle, MySQL, SQL Server, and Postgres databases, you can actually put your favorite self-managed caching tool on EC2 that then would be pointing to your RDS instance. In that case, the caching, though, just keep in mind that you will need to potentially change your application to take advantage of the cache. Therefore, in MySQL and in Postgres now, we do see a lot of interest in offloading read traffic to read replicas. And read replica is a native function of MySQL and Postgres. It essentially allows you to stand up a read-only instance of your database, and then we will asynchronously replicate transaction logs from your primary to your read replica. This allows you to then scale out from a read perspective, but still maintaining the same tool sets and fundamentally issuing SQL against that database. So of course here we want to have a little comparisons for read to write ratios. So in this case, we're going to do an example of MySQL, where my primary database has 90% reads and is taking 10% writes. So that's at this case, we're pretty much maxed out in terms of the capabilities or the usage of this database. So the first thing I might want to do is scale up by 1 time, right? In this case, I'm going to create 4 replicas. Now I still have the 10% reads because with MySQL, I'm replicating my bin logs. So I'll still incur the same amount of write utilization across all my replicas. However, now I can offload my reads to my read replicas, and you can see here that I can achieve 1x scale. By simply going to 2x scale, because the capability of the individual instances still has room to grow, I can go all the way up to 3 times scale. So again, we're not necessarily scaling writes very well because we're still replicating writes across all my replicas, but now I can dramatically increase my read performance and scale my operation that way. Now, if I have more, if I increase my writes to 20%, you'll see that my replicas now, because I'm replicating that 20% write capability across all my replicas, that essentially limits me to 2x scale. So I can have 4 replicas, and I'm increasing my reads, but I'm also proportionally increasing my writes. And so we have a summarization where if I can look at a 10% write ratio, I can actually scale pretty significantly, but as I increase my as I increase my writes across my replicas, I'll actually get limited scale because, again, we're replicating the writes across all of the instances as well. So the next thing to think about is, again, related to MySQL, which is cache warming. So in this case, it's a native function of MySQL 5.6 where I can actually save the state of the buffer pool. So when the application restarts, I don't have to then have a cold database to be able to uh, read from. So oftentimes when we talk about, failing over in a multi-AZ scenario, or in case of restarting the database based upon some kind of patching or some kind of external reason, um, it's great that I can automatically replace the host, or I can automatically fail over to my standby. But the downside of that is that once I fail over to my new primary database, that the uh, database cache is empty, and therefore I could have a period of time until the cache is filled again. So I will have, decreased response time for my application once I've done the failover, simply because the buffer cache has not been filled. So with MySQL 5.6, you can actually configure some parameters, and our benchmarks show that you can see up to 4x improvement in transactions per second by utilizing this feature of MySQL 5.6. So here's the two parameters that you can set within RDS MySQL to enable InnoDB cache warming. So let's talk about a couple of tricks there. So now we want to talk about monitoring next. So I mentioned in the beginning of the section around CloudWatch metrics, and CloudWatch is a native capability within RDS Engine to monitor resources in real time. You can collect and track metrics, as well as you provide visibility into performance, storage, and the number of database connections. And not only does it provide monitoring, but you can also set thresholds in which you can then be alerted based upon certain conditions. And we'll walk through what some of those can be. So here are the basics RDS metrics that we provide through CloudWatch. Of course, CPU utilization, free storage, free memory, database connections. And the important point I wanted to make about database connections is to remember that each of the four database engines have a parameter file associated with them that have default settings for database connections. So depending upon the nature of your application, we definitely encourage you to look into the parameter file to modify, potentially based upon your instance type and your application needs, the number of connections that the database can receive beyond just the default values. And so moving on to our metrics we provide, I/O in terms of reads and writes, as well as latency, throughput, and queue depth. And I wanted to talk a little bit about queue depth. So that's essentially the number of I/O requests in the queue waiting to be served. And from a best practice perspective, we talk about a queue depth of 5 for every 1,000 IOPS. So if that number is below 5 for every 1,000 IOPS, generally you're not using enough I/O generated, so you could potentially scale back your provisioned IOPS. What if it's more, then you might want to increase your IOPS, and that's potentially where you need to increase the amount of storage you have allocated, or increase the provisioned IOP ratio on that storage. So here's a couple, a quick little cheat sheet perhaps to be able to look at different metrics and then what actions I can take. So of course, if I have high CPU utilization, I want to be able to want to scale up my compute, which essentially could be either going to a new instance family or new instance type. If my freeable space is low, I'll of course want to scale my storage. If my free memory is down and swap usage is up, I could then scale compute, because remember that the compute instances contain both CPUs as well as memory. If my latency is high, I could potentially want to add provisioned IOPS. And if I have increased database connections, this is where I mentioned about my connection pooling and the parameters in the database itself. So hopefully this screen is kind of, hopefully it's not too small, but again, this is something in the console that you can easily test out. But this basically is showing the CloudWatch metrics and how I can then take those from a monitoring perspective and create alerts off of them. And this will essentially be where I can sign up for alerts. So here I can choose which metrics I want to be alerted on, and then how they want to be delivered, whether through SMS, SQS, HTTPS, or email. So there are different formats enabled to sign up for the alerts based upon my allocation of resources. So of course, from a best practice perspective, I think the minimum I would recommend is to of course, monitor your storage. And so when your storage gets to 75%, to receive some kind of alert to allocate more storage to your database, because of course that is a critical factor. And then, many customers will of course want to monitor CPU and IO throughput and get alerted based upon thresholds. But it's really up to you and your application to choose which of the alerts we're able to get alert, which of the metrics you want to get alerted on. So the next area to talk about is our parameter groups. And so parameter groups are essentially the way that we think about the configuration file for my database engine. And of course, the four engines being MySQL, Postgres, SQL Server, and Oracle. As you can imagine, they all have different configuration files. And so from an Oracle perspective, you might think about this as the init.aura, and I might want to modify some of those parameters based upon my application needs. So I can go into the parameter group, make my modification, and then save it, and I can even save it as a new name. And then when I launch a new instance, I can launch that instance with an instance type, allocated storage, and then a parameter group that I've named explicitly such that I don't have to recreate those values for each instance type. And of course, the ability to modify all the parameters is limited by the nature of a managed service. So you will see edit boxes for the parameters that we do allow you to edit. Of course, some of them would, as a managed service, not allow us to maintain our service level agreements, or potentially could cause problems in terms of a managed service. Therefore, they are grayed out. But of course, if there's a use case where you would like to have that, we're definitely welcome to take that feedback, and it's something that we're always evaluating. But the parameter groups are a key area because, of course, as a managed service, we're providing the basics in terms of high availability, backup, patching, installation. But there still is a subset of performance tuning that is responsibility of our customer DBA teams, and that would include, of course, schema design, SQL query tuning, but then, of course, some of the database parameters that you could see increased throughput performance by making better allocation of the configuration parameters that the database provides. So lastly, we're going to talk about a way to reduce costs. This is a little bit more of a simpler summary. So the ability to save money with RDS Reserved Instances. So one of the unique um, um, capabilities of Amazon is to actually pay a small upfront fee to get a lower hourly charge. And you can do that on a 1 or 3 year term. And it particularly makes sense for database workloads because, of course, there'll be a period of time where I'm testing, does RDS make sense for my application and for my organizational goals? Therefore, you can just use the on-demand pricing. You can very quickly stand up one of the RDS database engines. You can load data fairly simply, do your testing, but then once that testing period is over and you decide to move your application to RDS as the database engine behind it, you'll find that within just a short period of time, it makes more sense to move to at least to a 1 year reserved instance pricing at a minimum, if not a 3 year, to receive a significant discount. And it can definitely provide a lot of incentive to lower your bill for that course of that year, because once I've chosen a database engine and RDS as the place to host that database, most likely it's not a decision you would go back on a short period of time. So we definitely recommend looking at reserved instances, as well as, I again apologize for the graphics not coming through, but the interesting new combinations of the bursty instance types such as T2 and the GP2 storage in order to deliver outstanding performance for my application. So that comes to the end of my presentation. I think I'll turn it over to Sergey for a second to be able to answer some questions.